So, welcome to the next part of our video that was on refraction of light. In the last one, we saw that what is refraction and how do we define it, why does it happen, and what does it look like. So, most of the important part of what refraction actually is done. Okay, now we just need to formulate it. Okay, now in science it is really important to see a phenomenon, to observe a phenomenon, and to formulate it into our maths. And why is it important? Because it helps us build so many new things. So let's move to a bit of formulation. And the idea, the particular example that is given in your book to understand refraction properly is refraction in a glass slab, right? So we have a slab of glass, right? And this particular light ray hits this interface, right? So let me remove the highlight portion so that we can see it and then we can highlight it again. So this particular light ray hits this interface, right? What is an interface? Interface is nothing but the separation between the two mediums. This is the first medium and this is the second medium, right? So the separation between the place where two mediums meet is called the interface. So when the light hits the interface, it bends, right? That's the part what we call the refraction. And then it bends again when it hits the second interface, and then it just goes out parallelly to the ray that hit the first interface, right? Now, to formulate what's happening here, we have to see at which extent the light is bending, right? Like till where the light is bending. Okay, so let's say this is the surface, right? This is the the interface. Let's say this is the interface, right? Now, if I take a light ray and hit it with it, how much will it bend? How much will it bend? That's the question that we are asking. Okay, so to measure how much a light ray is bending, we can just measure this angle, right? You might be saying that we can measure this angle, but the thing is that this angle is dependent on the pair of media that we have taken, right? The pair of media that we have taken. So in our case, we have two pair of media. We have a pair of media, not two pair of media. We have a pair of media. So basically two mediums we can say, or two media we can say. As I said, media is the plural term of medium. Now we have two medium or two media. One is air and the other one is glass, right? They are two media. Now, the angle with which it bends depends on both of them. How shocking is that, right? Like if I replace this air, let's say it's not air, and this is water, right? This is water and this is still glass. Then this angle will change. Right? So how do we measure it? Okay. So to understand that, we'll have to understand the rules of refraction, right? That's the thing that we are going to learn here. So the first rule is very simple. You might have learned this rule in reflection also. The normal, the incident ray, and the refracted ray are in the same plane. Just to understand what is the normal is the line that makes 90-degree angle from the interface, right? So this blue line that you can see is the normal. This line that incidents or hits the interface is the incident ray, and this line, this light ray that refracts from the interface is called the refracted ray, right? So these three lines, 1, 2, and 3 are in the same plane. That's the first rule of refraction. You must have read the similar rule in reflection also. Now let's move to the second and the important rule of refraction. Okay. the first rule is something that you just have to remember. It's very easy because the similar rule exists in reflection also. Now let's see the second rule. It is quite important, right? So we had to find a relation between this I. What is I? Incident angle. Won't you say? That's an incident angle? Why is it an incident angle? Because the incident ray is making that angle from the normal. R is the refracted angle. Why is R the refracted angle? Because it's the angle that is made by the light and the normal in the media by which it has gotten refracted, right? This particular line has made this particular angle from the normal, right? Now, what is the relation that we find? The relation that we find is quite fascinating, and we find that sine of I divided by sine of R is equal to constant. For two media. Or a pair of mediums. Let's just call it properly media, right? So it's a constant for two media. So if it is air and if it is glass, then the ratio of incident angle sine and the refracted angle sine would remain constant. It's a very, very helpful law for us. Right? Now, it is only constant for two pair of media. Let's say I replace air with, I don't know, coconut oil, right? That's also quite transparent. I replace it with coconut oil and let's say it's glass only. Then the constant will change. And the constant will change the value of R will change. I is something that we can control. Because we are sending the light, right? So we can just, shift our laser pointer or whatever the source that we have. We can just shift it. I is something that we can control. But R is something that is controlled by the pair of media. Okay. So we name this constant a particular thing. Okay. And that thing is called a refractive index. Okay. What is refractive index? Refractive index basically tells us the extent of the change in direction that happens in a given pair of media. And the change in direction of light, I should have written of light, right? So how much will it bend? That's the question that we are trying to answer. How much will it bend? Will it bend this much? Will it bend this much? Okay. So this refractive index tells us how much will it bend. And how does it tell us? It tells us because it is defined the constant. The constant is defined as n21. Why am I writing n21? Let's make the diagram again, right? Let's say this is the glass slab. Let's say this is the incident ray. Let's say this is the, outgoing ray. And if bend slightly, I'm just making a very rough diagram here. Please bear with me. Okay. Bend slightly and the first medium, let's say it is the first medium is the second medium, right? The second medium. The constant is defined as sine I by sine R, right? That is called n21. Why do we define it as n21? Because we have defined it that this particular angle R and this particular angle I, they have this particular relation, right? So we call it the refractive index of the second medium with respect to the first medium, right? Refractive index of the second medium with respect to the first medium is called this particular thing, right? So that is what refractive index is. It tells us the extent. It tells us the angle actually. It gives us the angle. At which the light will bend in the another medium, right? Now we have a very beautiful relation with respect to refractive index and what it is. Refractive index basically n to 1 is basically equal to V1 by V2. And what are V1 by V2? What are V1 and V2? V1 is light speed. Light speed in the medium 1 basically. And V2 is light speed in 2, right? So we have this beautiful relation where if the refractive index of this particular material, let me highlight it, right? So you can understand it better. This refractive index of this particular material is given to us, right, in respect with the first media, then we can relate it with the light speed in the first medium and the second medium, right? That's why this relation is very important. And N12 correspondingly will be V2 by V1. N12, let's say N12 is given, right? N12 is, and what would be N12? N12 would be nothing but the inverse of N21, right? So we can just write N21 is equal to 1 by N1. We can just write that, right? There is no problem with that. Okay. So this relation is very important because we know refraction happens because of the light getting slower in different mediums, right? So there had to be a relation between the extent to which light bends and the speed that light gets in a particular medium, right? So this is the particular relation, and it is very simple. It is so elegant. We can remember it in seconds, right? Now let's talk about absolute refractive index. What is absolute, right? So we talked about reflective index. It was always relative. It was always relative. We said, what is N21? We said, what is N21? It is the refractive index of the second medium with respect to first medium. With respect to first medium, we change the first medium, the refractive index will change, right? But we wanted to standardize it. We wanted to have only one value, and it depending on the changing of material, right? Not on the changing of the other medium, right? We wanted an absolute refractive index. So what we did, we took the first medium. So this is the first medium, right? This is the first medium as vacuum or even air, because in air also light slows down very less. Light slows down very less, right? So air is as good as vacuum when it comes to refraction, right? Refraction of light, right? So this particular thing is clear, right? So if we take the first medium as vacuum or air, and we take the second material where actual refraction happens as anything, right? It can be glass, it can be plastic, it can be, coconut oil, cocoa oil, right? It can be, kerosene, whatever, right? This is the second material. The second material that we are finding the refractive index of, okay? And needless to say, this will also be the first media, okay? So when we take medium 1 as vacuum or air, the refractive index of the medium second is considered with respect to vacuum, and this is called the absolute refractive index. We can see some refractive indices. As I said, refractive index of air is very less. It's very less. Why it is very less? Because air doesn't slow down light that much. That's why it's very less. Ice, it increases a bit. Benzene, it increases even more. Ruby crystals, you have seen, it increases even more. And diamonds, right? It has a very high refractive index. Okay. Now, one thing to note, that rare and dense, when we say rare medium and dense medium, it doesn't mean, mass density. When we are saying rare and dense, it means optically rare and optically dense. There is a particular more to know section on the 149 page of your book that tells it that optically rare and optically dense and mass rare and mass dense are different things. Okay, so you can read it and take more idea. Okay,